Welcome back. Let's talk about the different factors that go into if a mass wasting event will occur, and if it does occur, what type of mass wasting event might we see. The rules aren't always cut and dry, but let's go through some of those factors, see if we can get a better understanding of what might start and be a characteristic of different mass wasting events. So the factors that go into what affects a mass wasting event are the types of Earth's materials, the angle of the slope and the topography, the climate, hot, cold, wet, dry, vegetation, some, none, water, and time. And we'll go through each of these very briefly. So, the first one, the type of Earth materials. Well, is it, first off, it's dictated by the mineral or rock composition. You know, if we're looking at, rock falls or rock flows or things of that nature, it depends on the mineral and rock type. Minerals and rocks break down differently. We also need to look at how well packed the material is. Is it more loose dirt and soil? Is it more compact? If there's any cracks or breaks in any of the rocks. So again, it first off depends on, well, what is the stuff that might move downhill? What is it? Is it rock? Is it dirt? If it's dirt, is it compact? Is it loose? If it's rock, what type of rock? Is there any breaks in it? Blah, 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 blah. So, again, if it's more rock material, we're looking at block slides, rock falls, topples. If we're talking and concerned more about the soil compaction and that type of material, landslides, debris flows, earth flows, creep. We also have to be concerned with the angle or the topography, how steep the incline is, because that goes into possibly dictating, well, what type of mass wasting event will we get. Remember, the difference between a debris flow and a debris avalanche is pretty much the same thing. It's just the debris avalanche is on a much steeper slope. And then it's kind of the same, the difference between a block slide and a rock fall. It's, block slide might be lower angle. It doesn't have to be, but it might be lower angle. Whereas a rock fall, now that this material is going to catch some air, going to be a free fall, probably needs to be a little bit more vertical. But, in general, if we have a slope made of dirt, maybe it's not very steep. Therefore, we're probably not going to get a landslide. You have to kind of have some angle to it in order to get some material moving downhill, whatever it is. Climate. This is a big one. Weather. So rain, snow, etc. The type and abundance of hillside vegetation is dictated by climate. In arid regions, dry regions, typically you'll have rock falls and or debris flows following some quick rain event, some flash flood event. In humid, wet regions, you might have complex landslides that might be some flow or translational or rotational landslide. Creep is also very possible. So the climate of the area will determine whether or not you get mass wasting, and if you do, what kind of mass wasting you get. Vegetation, it's kind of tied to climate. Different climates have different vegetation. But also different vegetation grows in different soil types. Some grow in loose dirt, some can grow on rocks. Topography, meaning some plants can grow in steep inclines, some need flat ground to grow on. And also fire history. What kind of wildfire has gone through and burnt out the vegetation in the area, if any? Because again, vegetation provides a protective cover that slows erosion. Erosion is the movement of earth materials, because roots add strength and cohesion to slope materials. It kind of tends to lock things in place. But the tricky thing about vegetation is that it's also adding weight to slopes. So it could also, even though it's holding stuff in, if there's too much plants, too many trees, then that might be too much weight for the slope, and that in itself could cause the movement of earth down slope. So different vegetation can dictate what's going on. Water. Water is almost always directly or indirectly involved some way shape, or form. Water, water, water. Let me say it again. Water, water, water. And before I say water one more time, let me give you part of the super secret code. It is the number 8. You got me? The number 8. So, if water saturates into a slope, into a hill, you might get some very shallow soil slips, so some kind of more surface landslides or creeps or debris flows. If you get kind of deep infiltration, water really soaking in, sometimes you can soak in really deep, and this movement can occur, even years afterwards. It can just soak in a lot of water, soak in a lot of water, soak in a lot of water. It's just soaking in because the type of the material can just absorb that. But at some point, years in the future, it could just go. And another interesting thing about water is that when water freezes, it expands. This becomes important, especially with kind of block slides and rock falls, or when we're dealing with kind of mostly rocky material, in that even the smallest drop of water, if it gets into a crack in a rock face, over time, ice acts as a wedge and can just crack rocks off. So water, even if it's one single drop, gets in a little crack of a rock, ice expands, and it will apply pressure on that rock over and over, and it freezes at night. And then during the daytime, the water melts, or the ice melts back to water. And then the next night, it freezes again. And then the next night, it freezes again. And the next night, it freezes again. And it just cracks a rock right open. You can just knock big pieces off to create things like block slides or rock falls or topples. But water pretty much has everything to do with all of these. Water soaking into the ground for landslides, quick precipitation, maybe not soaking in, but just moving along the surface, causing a debris flow or debris avalanche, etc., etc. And then time. Factors change with time. Climates change. Plate tectonics moves things around. So we're talking about time like on a seasonal level all the way up until, a geologic level. So, with seasons, you get changes in moisture. With plate tectonics, you get changes in climate. And all of these things can facilitate mass wasting. All right? But again, water pretty much always has something to do with it. But you have to really consider all of these different characteristics. So let's go ahead and pause here. When we come back, we'll look at some regions at risk around the U.S. for mass wasting events, including Arizona. I'll see you back here in just a second.